We used to take them, you can roll them in and out of a furnace, right? So you take them in at 1500 degrees, you let them sit for 3 hours, you bring them out, you can weld on them for a couple hours, you take them back in, and then you let them sit for a while, you bring them back out, do a couple more welds, put it back in. They had to keep them between a certain heat zone to let the grain structure and the metallurgy disperse at the same time, okay? That's when things like this, particularly on surfacing welds, you might see this situation, okay? Line boring on equipment, same thing. Sometimes when you're line boring, you'll have a specific machine that'll build it up in this direction, and then every once in a while, you might see somebody that's gonna switch up the bore in the other pattern, okay? Just to kind of get them to where they don't cut the same path or the same grain. Sometimes they can wear out faster in that way, by doing that. NDE symbols. All right, examine all around, field examination, radiation, direction, okay? So that is going to tell us quite simply the
That was the last slide.
Yeah. Well, that's not a very good slide. Right? Jeez. Okay, a few things that we need to worry about. We talked about them in the book. Write them on the board real quick. And then we'll be done. So the first of all, let's talk about the different types of methods. You can look in your book and you can see that on your own as well, plus, but if you haven't bought the book, it can be a little difficult. And we're going to cover quite a few more of them. Now I know why I didn't do it, because it's actually back in chapter 10. This is where we talk about NDE methods and symbols. Because that makes sense. Right? I'm going to talk about symbols, but in chapter 4, the NDE methods will be in the back. So we're just going to hit the highlights. The different types. You can also find this in your actual welding book as well. So RT, radiographic testing, X-ray, right? UT, ultrasonic testing, VT, visual testing, most economical one we make, right? Use the welder, control it, see it, everything else. PT, penetrant testing, eddy current testing, and magnetic particle is usually considered to be MT as well, okay? We're going to break down those individual pieces at another time in chapter 10. We get into visual inspection, why we're going to do that. But the couple things that I want to bring up out of this for symbols that you might see would be basically, I want you to get a reference of chapters 10-27, and I'll try to take a picture of it as well. I'm just going to get a reference here of. It looks just like our normal welding symbol, okay? And basically, it tells us the number of examinations on top, like we see in the 5 in the spot earlier. The tail will give us our spec or our omission. And I'll see if I can get a picture of this out and put on the Blackboard site, okay? So, why is some of this stuff important? Number of examinations. Certain companies will tell us that only 20% need to be welded, or need to be examined or x-rayed. Unfortunately, here's what happens in the real world. The best welders in the world weld the first 20% of the welds, right? They make $200 an hour. They're going to weld the first 20%, they get x-rayed. Once those pass, a lot of times everybody else comes in, half wages. Totally true. Not supposed to be that way, but the reality of it is that is exactly what happens. So what do? How do they spec it? So companies got smarter about that, especially insurance companies, right? especially when they're talking about pressure, steam, and everything else, and boiler. Some of them, when the boilers, just every one of them, especially residential homes, have to be inspected. But, what they will tell you a lot of times is they may say this, is it might say RT all the way around, okay? And it might tell you 20%, and then it'll tell you usually in detail A, and it'll tell you a random 20% spread over a certain time, and they might have a different contract out there, okay? Because typically, if not, what would happen is the company would save themselves money, because our RT's expensive, you gotta clear out everybody as well, is you got 1,000 welds, the first 200 welds they're gonna do, they're gonna, on with the good welders that have no problems, take their time, they're gonna bring the x-ray person in, shut the job down for a week, they're gonna x-ray those first 200 welds, and then the other 800 welds are gonna be done by welders that maybe, quite possibly, aren't as good as the other ones, right? Flaws, catch up their money, make some serious money on top of it, but they do get a lot better about it instead. When we get into 10, we'll talk a little bit about the direction of radiation source, because it goes a lot more in depth than that too. It tells you what blocks, what specs, what angles, what power, what all sorts of things in there, right? Whether it be X-ray or whether it's by source, those are also things that matter, so forth. All right, I think that's all I have for this. Any questions? Go ahead and read through, get the book and look through 10-28, put those things in your symbols, key terms and definitions. Let me switch back to chapter 4. Quick. Things I definitely want you to understand out of that are going to be complete. We'll start page 4-81. Actual throat, back weld, backing weld, backstep sequence, block sequence, boxing, buttering, butt joint, cascade sequence, chain intermittent fillet, complete joint penetration, effective throat, face reinforcement, feigned surface, fusion face, groove face, joint type, non-butting member, root edge and root face for sure, root reinforcement, scarf weld, staggered intermittent fillet weld, stud weld, theoretical throat, weld interface, weld reinforcement, and weld toe. All right, that's all I have for today. Thank you. This is the end of chapter 4.